Hi, in this video, we are going to talk about how to manipulate exponents to figure out if a function is exponential growth or exponential decay. Now, a typical exponential function has the form y equals ab to the t, where a is your initial and b is your growth or decay factor. So the entire base is called the growth factor, and then we need to see whether it's greater than 1 or less than 1 to figure out the growth or decay rate. So if you are exponential growth, then b is going to be greater than 1. That means you are going to set up the equation that 1 plus r equals your base and solve for r. If you have exponential decay, then your base is between 0 and 1, and that means you're going to set up the equation 1 minus r equals d. So from there, let's talk about how we can always figure out what our base is if t is not by itself. Because notice how in this example, you have to the t power, it's 1t. And in all of these examples below, t is not by itself, and that's a problem for us. Because while this looks like you have a base that's less than 1, and it looks like it's decaying, it's not. So in order to figure out if you're exponential growth or exponential decay, t has to be by itself. It needs to be 1t. And right now we have negative t, so that's not okay. So what we're going to do is we're going to put everything in the calculator, and by everything I mean the base, 1/2, and the coefficient of your exponent. Now your coefficient is -1. So what I have is parentheses, alpha y equals 1/2 parentheses to the -1 that's in front of our t. And it's going to show us what our true base is. Our true base is 2. So I'm going to rewrite this as y equals 2 to the t power. I got rid of the -1 in front, and now it's just t, which shows me that now actually I have something that is exponential growth because my base is really greater than 1. And if you want to find your rate, you would need to set up the equation 2 equals 1 plus r, and then solve for what r would be, and you would get 1 equals r. So your rate is 1 or 100%. This is growing by 100%, which means it's doubling. Anyway, let's try the next one. You don't have just 1.2t. 1.2 to the t power is exponential growth. No idea what 1.2 to the 3t is. So you're going to take your base, and you're going to take the coefficient in front of the variable exponent, and you're going to put it in the calculator. 1.2 to the third power tells me it's 1.728. And I'm going to rewrite the equation as y equals 1.728. And now, because I got rid of the 3 with the calculator, I have just t as my exponent. I can tell that that is exponential growth. And if you need to set up the equation for yourself, go ahead. You have 1.728 equals 1 plus r. You end up with r is 0.728. Although this question does tell us to round to the nearest hundredth, so I'm going to go and rewrite this as 0.73. So we're increasing by about 73%. Big jump. Let's look at the next one. We have 2 Oh, this is hard to trace. 2 to the 0.3t. So it looks like we are doubling, but we have a 0.3 in front of the exponent. So, or rather in front of the variable. So 2 to the 0.3, everything in front of the variable needs to go in the calculator. And that's going to show me y equals 1 point, oh, you know what? I'm going to round to the nearest hundredth now. I'm going to write this as 2, 3. So for this particular one, originally it looked like we were growing by a lot, but when we got the t by itself, now you just have 1.23. It's still exponential growth, but it's really not increasing by as much as I thought it would be originally. Now it's only increasing by 23%. Let's try the next one. It looks like we're increasing a lot. It looks like we're increasing because we have a base that's way greater than 1, but you have a negative exponent. Now, if you remember, negative exponents create fractions. So really, I think the 5 is going to turn into a fraction, and we're not increasing by as much as we thought. But let's try it. There's a negative 1 in front of the t. So you have 5 to the negative 1, and that's going to be 0.2. So we have y equals 0.2 to the t. That shows me I'm exponential decay. If you need it, you have that 0.2 equals 1 minus r. And if you have to, you can solve for r, but think about it. If you're starting at 100% and you went down to 20%, that's because you are decreasing by 80%.